In this video, we will talk about carboxylic acids and esters. As the name implies, carboxylic acids are weak acids. These hydrocarbons have the functional group carboxyl, or COOH. It is interesting because this carboxyl group is actually two functional groups put together. It is a carbonyl group, which is C double bond O, and a hydroxyl group, the OH. You must be careful in not confusing the presence of the hydroxyl group as being an alcohol. If the hydroxyl group is attached to a carbonyl group, it is considered a carboxyl group, and therefore it is a carboxylic acid. As well, the COOH carboxyl group is always at the end of the carbon chain or branch. These carboxylic acids, as we mentioned, are weak acids. Therefore, they make food taste sour or tangy and are naturally found in citrus fruits and other sour-tasting plants. They are polar because of their C double bond O bond as well as their OH. This OH provides them with a hydrogen bonding capability, and they hydrogen bonds with other carboxylic acids as well as water. These carboxylic acids have a similar solubility as alcohols. So if there's 1 to 4 carbon atoms, they're very miscible with water. But if they have greater than 4 carbon atoms, their hydrocarbon chain makes them less polar and they're not miscible with water. When naming carboxylic acids, we merely drop the E from the alkyl name and add the letters OiC and the word acid. Therefore, the most simple carboxylic acid is methanoic acid, which is merely C double bond O with an OH. And to complete the octet for a carbon, we add 1H. This is also known as formic acid, which is the venom in red fire ants that they inject into their prey. The second carboxylic acid is CH3COOH. You'll notice that there's 2 carbons, and therefore this has the root of ethane, but now it's ethanoic acid. And this is also known as acetic acid or vinegar. Ethanoic acid has the structural formula CH3, C, double bond oxygen, single bond OH. When naming carboxylic acids, it is also possible to have branch compounds. However, these branches are named merely as a prefix. So if we're to look at this compound, we see that there are 5 carbons on the main chain. Therefore, it is going to be a pentanoic acid of some sort. And then we note that there is a carbon or a methyl branch at position 3. So the final name of this compound is 3-methyl pentanoic acid. Carboxylic acids undergo what's called an esterification reaction when it is reacted with alcohol. So again, an acid plus an alcohol in the presence of sulfuric acid will produce what is called an ester. Here, the slightly grayed out portion of the carboxylic acid becomes this part of the ester. You'll notice that this part has the carbonyl compound or functional group attached to it, the C double bond O. And in the alcohol, there is what's called the R prime group. The R prime denotes that it is an alkane branch, but it is a different alkane branch than the one coming from the carboxylic acid. Notice that the hydroxyl group from the carboxylic acid and the hydrogen from the alcohol has been removed in the ester compound. However, they recombine to form water as a product as well. The product of an esterification reaction is an ester and a water. Now, this ester is the last functional group that you need to be aware of. These esters are very similar to carboxylic acids in that they have a carbonyl functional group. However, instead of having a hydroxide attached to it, they merely have an O and another hydrocarbon compound. Because there is a hydrocarbon compound or an alkyl group, esters are also known as alkylated carboxyl groups. Esters, just like carboxylic acids, are found in plants, and these ester compounds are very fragrant. They create many of the odors and smells that we associate with fruits and flowers. Chemists can also produce these esters in industrial processes, and these are added to foods as artificial flavorings. As well, they can be used as cosmetics, perfumes, fibers, or even as solvents. Here are a handful of ester products that have been chemically synthesized, or can be found in nature. Here we have methyl salicylic, which is found in chewing gum and can be easily made in high school reactions. Here we have ethyl cinnamate, which smells like cinnamon. Banana smells can be made from isoamyl acetate. Pineapple smells can be made from methyl butyrate, and a lot of the other fruits flavors. When we name esters, we have to consider which alcohol and which carboxylic acid they were derived from. The first part of the name for esters is just the alkyl name of the alcohol. And then the second part of the name, we change from whatever oic acid into OAte. An example is the reaction of butanoic acid with methanol to produce methyl butanoate. Notice here the CH3O part of methanol is found on the right-hand side of the diagram as it is drawn here. The methyl group is attached to the oxygen of the methanol, whereas the carboxylic acid component, the butanoic part, remember this has the carbonyl group attached to it. The carbonyl group can be found here, and here is your butanoic part. We always name the esters with the alcohol name first, so methyl butanoate. Here is another naming example. First, we have to identify which carboxylic acid this ester was derived from. We see that there are 3 carbons on the carbonyl end of the ester. Therefore, we know that is a propanoic acid. Remember, we dropped the oic acid part and we replace it with OAte. Therefore, the root name of this ester is propanoate. Now we look at what alcohol was used to derive this ester. Here we see that the alcohol was a single carbon alcohol, or a methyl group, and this is our prefix. So then our final name of the compound is methyl propanoate. Here is a summary of all the hydrocarbon compounds that you need to be familiar with in Chemistry 30. The most simple form is our alkane, which is a saturated molecule. The next one that you need to know is an alkene, which is a double bond compound. Alkyne is next, where there is a triple bond. The next one is an alcohol, where there is a OH group attached to our hydrocarbon. And alkyl halide has a halogen attached to the carbon atom. Our carboxylic acid has a carboxyl acid group attached to it. So again, it's a C double bond OH. And lastly, an ester has a alkylated ester group to it, which is a C double bond O, single bond O, and another carbon branch.